Hi, this is Mir Shaukat Hussain, teacher from Zone Bikepora, District Badgam of JNK. Today, the topic I have selected is work. That is, what is work or when work is said to be done. Even though the term work seems to be simple, but in real sense, it is not simple, it's a complex one. Because what we mean by work in day to day or everyday life is totally different. What is its meaning in science? So let us begin. Before defining work, let us see what are various objectives that will be fulfilled in this video or in this class. First is meaning of work. That means we will be able to understand what is the meaning of work, what is its meaning in day-to-day life as well as in scientific terms. Second, what are the various expressions or formulas for calculating work done under different conditions. And third, what is nature of work or types of work. Let us have a look on some examples. Here are some pictures showing different persons are doing different things. In first case or in first picture, a man is holding a bundle of hay on his head. Is he doing any work? In common language, we'll say yes, he is doing work. But science says he is not doing any work. In second case, a person is carrying a suitcase in his hand. Is he doing any work? In common language, we'll say yes, he is doing work. But science says he is not doing any work. In case third or picture third, a person is reading a book. Is he doing any work? In common language, we'll say yes, he is doing work. But in science, he is not doing any work. In last case, a person is shown writing something. Is he doing any work? In day-to-day language, we'll say yes, he is doing work. But science says he is not doing any work. That means the meaning of work in day-to-day language is different from what is its meaning in science. So we came to know that meaning of work in day-to-day life is different. What do we mean by it in science? That is what I said in the beginning. Even though the term work seems to be simple, but in real sense it is complex. So let us remove the complexness of work and make it easy for you to understand. So let's begin with the title, that what is actually meaning of work in everyday life. In everyday life, work simply means any sort of physical or mental effort. If a person is applying any physical effort in everyday life, we say work is done. If a person is applying or utilizing a mental effort, we said in everyday life work is done. Let us analyze the four examples. First, a man is holding a bundle of hay on his head. So definitely he is applying a physical effort. So in day-to-day life, he is doing work. Second, a man carrying suitcase again is applying a physical effort. So he is doing work in day-to-day language. Third, a man reading a book, he is not applying here any physical effort. He is using his mental effort. So again, mental effort in common language means work. So he is also doing a work. And lastly, a person writing anything is also exerting or applying mental effort. So he is also doing work in day-to-day life. So in short, whenever a person uses any physical effort or mental effort, he is said to have done or he is said to be doing work in day-to-day language. So far, we have understood what is meaning of work in our day-to-day life. Now let's come to the field of science or physics. Let us see in science what is meaning of work. In science or physics, work is said to be done by a force when it displaces a body in any direction but not in a direction perpendicular to itself. That is applied force. So, in science, work is said to be done when a force is applied on any body and displacement is produced in a body, but the direction of displacement is not perpendicular to the applied force. So we can conclude that in science, work is said to be done when three conditions are fulfilled. But all the three conditions should be fulfilled, then we can say work is done. First condition is application of force. That means force should be applied. Second, in production of displacement. On the application of force, displacement should be produced. And third, the angle between the applied force and the displacement should not be 90 degree. If all the three conditions are fulfilled, work is said to be done. If all the three conditions are not fulfilled, then work is not said to be done in science. That is, if there is no application of force, no work is done. If force is applied but displacement is not produced, again no work is done. If force is applied, displacement is produced, but the direction of displacement is perpendicular to the direction of applied force, then again no work is done in science. So in science, work is said to be done when a force is applied which produces a displacement in the body and the displacement is not perpendicular to the direction of the applied force. Now let us have a look on these examples. In first case, a man is holding a bundle of hay on his head. In day-to-day language, we know he is today doing work, but in science he is not doing any work because here he is just holding the bundle of hay on his head. There is no displacement. So when there is no displacement, work done is zero. In case second, a man is reading a book. So in day-to-day language, he is doing work as he is applying mental effort. But in science, he is not doing work because he is neither applying force nor there is any displacement. So no work is done as per science. In case third, a man is drawing a man is drawing water from a well. Is he doing work as per science? Yes, he is doing work as per science because he is applying force to remove the bucket from the well, and displacement is produced as bucket comes out of the well. At the same time, the direction of force and displacement are the same. So work is done here because all the three conditions are fulfilled. First, force is being applied, displacement is produced, and the angle between force and displacement is not 90 degree. Another example is a horse is pulling a cart. Is he doing a work? Answer is yes. In science, he is doing a work because when horse pulls a cart, he applies a force on the cart. At the same time, cart moves, so displacement is produced, and the angle between force and displacement is not 90 degree because horse pulls the cart forward in forward direction and cart also moves in forward direction. That means applied force and displacement are in the same direction, so work is done. So I think it is clear from these very examples also that work is done only when three conditions are fulfilled. First, force is being applied, displacement is produced, and the angle between displacement and this direction of the applied force is not 90 degree. If we will take the example, if we will look on the example of a person carrying a suitcase in his hand, he is not doing work. The reason is he is applying a force in upward direction and moving in forward direction. So the angle between applied force and the direction of displacement is 90 degree. So no work is done when a man is carrying a suitcase in his hand. I think now it is clear that the meaning of work in day-to-day life is different what is its meaning in science. Now let's see what are various expressions for calculating work done on application of force. The general expression or formula for calculating work done on application of a force, yeah, by a force, is work is equal to displacement into component of the force in the direction of displacement. That means when a force is applied in a body and displacement is produced but not in a direction perpendicular to the direction of force, if we want work is done, and if we want to calculate the work done, we have to multiply the displacement produced by the component of force in the direction of displacement. Now let us analyze it in two cases. First, let us see what will be the expression of work when force and displacement are in the same direction. And in second case, we will see what is the expression or formula for calculating the work done when force and displacement are inclined to each other at some angle. Now let's take the first case. We'll find the expression for work done when force and displacement are in the same direction. Uh, just see the picture below. A person is pushing the cart in forward direction, and the very cart is also moving in that direction. That means applied force and displacement of the object are in the same direction. In this case, whole force is utilized in doing the work. That means whole force is in the direction of the displacement. As we know, expression for the work is displacement into component of force in the direction of displacement. As in this case, a whole force is in the direction of displacement, so we can say the component of force in the direction of displacement is whole force. So the expression for the work will become displacement into force, or we can say force into displacement. So work is equal to F into S. So in short, when force and displacement are in the same direction, the expression for the work done is for F into S, applied force into displacement. That means we need to multiply applied force by the displacement produced, and we will get the work done. Now let's see the expression for the work done when force and displacement are not in the same direction but inclined to each other at some angle. When force and displacement are inclined to each other at some angle, as shown in the figure, then the horizontal component of the force is involved in doing the work. That is, as is indicated in the figure, force and displacement are not in the same direction, but force and displacement are inclined at some angle, suppose theta. So we need to resolve the force into two components, horizontal component and vertical component. Horizontal component of this force is F cos theta, while as it is vertical component will be sin theta. As is evident from the diagram that only horizontal component of the force is in the direction of displacement. So work done in case will be F into S into cos of theta. That means displacement into component of the force in the direction of displacement. Since the component of the force in the direction of displacement is F cos theta, so the expression for the work will be S into F cos theta or F into S into cos of theta. So it is clear that if force and displacement are in the same direction, expression for the work done will be F into S, force and displacement. But if force and displacement are inclined to some angle theta, then the expression for the work becomes F S into cos of theta. Nature of work, or you may say types of work, depending upon the angle between force and displacement, we can divide work into three types: positive work, negative work, and zero work. Now let us have a look on them one by one. Positive work. What do we mean by positive work? Work done is said to be positive if the angle between applied force and displacement produced is less than 90 degree. So when the angle between applied force and the displacement produced is less than 90 degree, we say work is positive. Let's go some examples. Work done by engine in pulling train. When a train engine of a train pulls the train, the engine pulls the train in forward direction, and train also moves in the same direction. That means force and displacement are in the same direction. In other words, the angle between the applied force and the displacement produced is 0 degree, which is less than 90 degree. The work done is positive. Another example is work done by horse in pulling a cart. Horse also pulls the cart in forward direction, and cart also moves in the same direction. That means force applied by the horse and displacement of the cart, they are both in the same direction. So the angle between the two is 0 degree, that is less than 90 degree. So work done in this case is also positive. Negative work. Work done is said to be negative if the angle between applied force and displacement produced is greater than 90 degree. So if the angle between applied force and displacement produced is greater than 90 degree, the work done is said to be negative. For example, work done by force of friction. As force of friction acts in the direction opposed to the motion of the body, so angle between the applied force and displacement is 180 degree, which is greater than 90 degree. So work done by friction is negative work. Similarly, work done by brakes in stopping a bicycle is also negative, as angle here is again 180 degree, which is greater than 90 degree. Zero work. Work done is said to be zero if the angle between the applied force and displacement produced is equal to 90 degree. So if the applied force and displacement produced are at right angles to each other, then the work done is said to be zero. Let us see some examples. Work done by a coolie in carrying a load on his head is zero work, because the force applied by the coolie on the load is acts in upward direction while displacement is in forward direction. So the direction of displacement and the direction of applied force are inclined to each other at an angle of 90 degree. So no work is done, or work done is zero. Similarly, a man carrying a suitcase in his hand has done a zero work, or you can say no work, because he is applying force on suitcase in upward direction and displacement is produced in forward direction. Again, the angle between the applied force and displacement produced is 90 degree. So work done is zero. So I'm sure that the concept regarding work is now clear. We have now clear knowledge about what is meaning of work in day-to-day life, what is its meaning is in science, what are various expressions for calculating work done in different cases, and what are different types of work. Thank you.